66 million years ago, a dinosaur roamed what is now modern-day Montana. It was a tyrannosaurid, but much more slender and gracile than the famous Tyrannosaurus rex, which it lived alongside. So, what was this dinosaur? Well, that's where it gets complicated. Depending on who you ask, this dinosaur either represents the infamous genus Nanotyrannus, or it's just an earlier growth stage of the aforementioned T-Rex. So, how did one dinosaur create such a divide on what it represents? Well, this whole debate started in the 1940s, when the specimen CMNH7541 was discovered. This is the number given to a skull that was uncovered in the Lance Formation of Montana, and upon its discovery, it was classified as belonging to a new species of Gorgosaurus. Since then, however, the skull has proven to be a taxonomic mess. In 1970, it was reassigned to a new Albertensis species. Then, in 1988, it was given its own genus name, Nanotyrannus. This name was given to the specimen by the famous paleontologist Robert T. Bakker, who pointed out several differences the skull had from other tyrannosaurids, such as a very slender snout relative to skull length, more teeth than Tyrannosaurus rex, and fused cranial bones that suggested the animal was fully grown when it died. Thus, the species Nanotyrannus lancensis was coined. But this didn't stick for long. In the 1990s, more was revealed about the growth stages of tyrannosaurids such as Tarbosaurus, which showed that these animals started life as smaller gracile animals before experiencing a massive growth spurt around the age of 15 into the more traditional, robust forms. Couple this with the findings that fused cranial bones may not be an accurate indicator of dinosaur age, and the fact that tyrannosaurids lost teeth as they grew, this led Dr. Thomas Carr in 1999 to suggest that Nanotyrannus was, in fact, a juvenile T-Rex, citing both the previously mentioned evidence and the lack of any other Nanotyrannus specimens as proof of this. This theory was later reinforced by the discovery of the specimen known as Jane. Although initially suggested to be an adult specimen of Nanotyrannus based on multiple shared characteristics with the original skull and the presence of supposed adult features in the postcranial skeleton, bone histology later revealed that Jane was an immature specimen, and that any differences this specimen had with Tyrannosaurus rex adults were the result of either ontogeny or individual variation. Furthermore, in 2020, Thomas Carr published a study that analysed 1,850 morphological characteristics across 44 specimens of Tyrannosaurus. This study found that both the Jane specimen and the holotype of Nanotyrannus did not represent a different species, but instead represented different growth stages. All this seemingly put an end to the genus once and for all. That was until 2024, when a new paper was published that seemingly revived the genus and the debate once more. The paper used a similar approach to Carr's 2020 study, this time analysing 185 morphological characteristics across close to 30 specimens, and found that the supposed Nanotyrannus specimens and T-Rex specimens grouped together into two separate groups with no intermediate specimens, which you would expect to see if these represented growth stages. Further histological analysis of the Jane specimen and another specimen called PT showed that the bones have growth rings that formed closer together once the animal died. This suggested that the specimens were slowing down their growth and reaching their full size, meaning these may indeed represent adult specimens. All this led the authors to suggest that Nanotyrannus is indeed its own genus, and doesn't represent a younger growth stage of Tyrannosaurus. Still, as to be expected, this has been debated. So with all this back and forth caused by the simple fact that these young T-Rex or Nanotyrannus specimens look so different from other Tyrannosaurus rexes, surely the next question to ask is why they look so different. Well, if Nanotyrannus is valid, then the reason for it being this much more gracile, medium-sized Tyrannosaurid may result from this niche being empty in its home of Hell Creek. Several authors pointed out that within the Hell Creek Formation, the formation where the nanospecimens were found, there is a large disparity between carnivore sizes, with multiple smaller carnivores and the enormous Tyrannosaurus being the only ones found. This contrasts with places such as Africa, where there is a much more even spread of carnivore sizes to fill different predatory niches. If Nanotyrannus is indeed its own genus, then this would help fill this gap and allow it to coexist with other carnivores. However, if they are young T-Rexes, the different body shapes may be the result of what is known as ontogenetic niche partitioning. This is the process where different age groups of the same species have different morphological characteristics that help them feed on different resources to reduce intraspecific competition. This is shown best in the crocodiles, one of the dinosaurs' closest living relatives. Young crocs have much more slender and longer snouts built to catch small prey such as insects. They also exhibit a much more semi-aquatic lifestyle. In contrast, as they grow older, the snout becomes much shorter and broader to catch larger prey, and they also seemingly adopt a much more aquatic lifestyle. These changes are so that the young animals don't have to compete with the much larger adults for food, and this may explain why young tyrannosaurs are so different. For example, one of the differences pointed out by the 2024 study was the much larger arms and claws of the supposed Nanotyrannus specimens. This change from large to tiny arms was seen as too great to explain by ontogeny, but this may not be true. This feature may have resulted from the young needing these long claws and arms to hunt and capture prey. However, once they reached adulthood, they no longer needed such long arms, and thus reabsorbed the calcium to be used elsewhere. This wouldn't be the first time this has been found in dinosaurs, as in Triceratops, the younger individuals possess triangular bones along their frills, but as they get older, these bones are reabsorbed back into the frill. So, as you can see, this debate will no doubt rage on for many more years to come, with both sides having evidence for and against the validity of Nanotyrannus. However, one fossil may solve this debate once and for all. Nicknamed the dueling dinosaurs, this fossil preserves an adult Triceratops and a juvenile T-Rex supposedly locked in combat. As you may expect, some researchers have suggested that the juvenile T-Rex in the fossil may represent a Nanotyrannus specimen. However, the specimen has yet to be properly analysed, as although it was discovered in 2006, the fossil was caught up in legal troubles that prevented scientists from researching it. But with the find now at the North Carolina Museum of Natural Sciences, paleontologists finally have a chance to study it. So, who knows, this Tyrannosaurus specimen may prove Nanotyrannus' validity once and for all, or it will tell us exactly what changes T-Rex underwent throughout its life. Either way, I'll be glad once this paleontological headache is over. And if you want to learn about other debated topics in paleontology, click the video on the screen. Until next time, bye-bye.